So this is actual real code taken from an e-commerce site that it was my first developer job. It was a site called Doggy, which may or may not still exist. I guess I could find out right now, right? Of course, this is all on tape. Moment of truth. Yeah, it still exists. Okay. So my first developer job after school was, I guess I could bring it back up, was Doggy, which is, at the time that this started, it was the time that Groupon was just gaining traction. Since then, Groupon is not what it once was, but at the time, everyone wanted to be Groupon. Groupon was like the biggest tech thing in Chicago. So a bunch of people got together and started Doggy, which is a Groupon clone, basically like a deal a day for dog-related products. I don't work there anymore, so this is not an advertisement for Doggy, but ooh, I didn't do that. So when the yeah, and I didn't do okay, that's not bad. Okay. Well, it looks nothing like when I worked there. This is years ago. So the code that you saw there was pretty much the same exact code that really existed in the website. So this is real stuff. Basically, it represents, not that. It represents somebody buying a product. And at Doggy Loot, at the time anyway, we offered store credit. You can earn credit by referring a friend and other, I guess if you return something, maybe you get store credit. So there's basically two paths that someone might have. Someone might have, well, everyone has a certain amount of store credit. Your store credit might be 0, but everyone has a store credit assigned to them, some number. So there's two, in calculating how much a person would owe when they have store credit and how much they would pay with their credit card when they have store credit can really follow two possible paths depending on whether someone has enough store credit to cover the entire purchase, or the alternative where someone has either no store credit or just partial store credit that only covers part of the purchase. And that affects the logic of how we do our calculations when charging them. So in the first example, or in the first part of our condition, if someone has less store credit than the amount they owe. So let's just use real life examples to make it a little easier to understand. So let's imagine that you're buying, I know what example I'm going to use. The best product we've ever sold at Doggy Loot when I was there was you can buy, I think the cost was like $100, but everything on Doggy Loot is like really, discounted prices. So you get it for only $50, a session with a dog psychic. And what the psychics specialize in communicating with your deceased pet. And when we put this on the site, I was so excited. I was like, I just want to see how many people buy this. And I think like 4 people bought it. Really low compared to some of the other products we sold. But I mean, I'm just picturing the situation. I'm picturing a scenario like I'm talking to the psychic, and like, please tell me what my deceased Fido is saying. Psychic's like, I hear him. She's saying, bow wow, wow, wow. Like, I could have done that. So let's say that you're purchasing that deal. The amount due, you owe $50. Because that's how much the psychic costs. But let's say you have some store credit. But your store credit is, let's say, less than $50. Let's say it's only, okay, good example, $25. So let's walk through this. If your store credit is less than amount due, which is the case in this example, and someone pointed out correctly in their Slack to me that this code actually will throw an error because none of these variables have been defined yet. But this is sort of like taken from like the middle of greater context of code. So just imagine that we established, I guess we sort of could, I guess, right? We could just establish them here. Amount due is 50, and then store credit is 25, and then it would run. So if the store credit is less than the amount due, then the amount due after spending your credit becomes amount due minus store credit. So it's sort of hard to, at first, perhaps to reason about, but basically we're decreasing amount due by your store credit. So if your amount due is $50 and your store credit is $25, Ruby calculates that immediately as $25. So the amount due is now $25 because you're using $25 of your store credit towards the purchase of $50. So now your amount due is going to be, you only owe on your credit card, you only owe $25 because you're using $25 of your store credit. Does that make sense so far? Now, since you're using your store credit, we have to save that data as well. And you've used all your store credit because you didn't even have enough store credit to make the entire purchase. So you depleted your store credit. Your store credit, we know for a fact, by definition, if your store credit was less than your amount due and you're using as much store credit as you have towards that purchase, then by definition, now your store credit is going to be reduced to $0. Does that make sense? It's tricky. It's trickier to write this. And I have a good story about that too. Questions about this? Okay, now let's do the other scenario where I refer all my friends to Doggy. I just referred 17 people to Doggy. So I have tons of store credit. So I have $1,000 in store credit. And I just want to buy, I don't really believe in the psychic, but I have $1,000 in store credit. I can pretty much buy anything on Doggy. So I'm going to buy that. So in this case, the amount due is still $50, but I've got $1,000 in store credit. So in this case, the other fork in the road of the conditional gets triggered, right? Because if store credit is less than amount due is no longer applicable to our scenario, right? Because our store credit is not less than our amount due. Our store credit is way more than our amount due, right? So the else is what gets triggered. The else can be said in English as
if amount due is not greater than store credit.
Yeah, if amount due, and another way to say it, which I'll prefer this way in this scenario, is amount due is either store credit is either equal to or greater than amount due, which is the same thing that you said, just different words. Just easier, I think, in this scenario to think about it that way. So basically, if I have enough store credit to pay for this purchase, maybe I'm using all of it towards the purchase, but I have enough. In that case, we're not going to wipe your store credit down to 0, right? Because you're only using part of your store credit to cover the entire purchase. But we do have to reduce your store credit according to what you're using here. So store credit now needs to be updated to be whatever store credit minus amount due is. Basically, we're reducing your store credit by whatever you're buying. So I'm spending $50 of my Doggy Loot dollars, I think they were called. So now my store credit is now what? $950. I have $950 Doggy Loot dollars. But since I paid for this whole thing in store credit, my amount due is now 0, right? At least on my credit card, right? I reduced my Doggy Loot dollars, but I don't have to pay anything on my credit card. Does that make sense? This is perhaps the first realistic scenario you encountered tonight in where conditionals are used in real life. Now, in our code, in the real life, like in the Ruby on Rails site, we wouldn't have these variables created there. Basically, what we do is pull from the database and see how much, let's look up this user in the database. Let's see how much he or she is buying now, spending now. Let's see how much he or she has in Doggy Loot dollars. We pull those and then create the variables out of the database and then proceed with the remaining code. Yeah?
How are you supposed to do that if we didn't have that information above? You just presented us with that.
But anyway, I took over from the original developer, and I came to this section and I was already working there for quite a few months until I really sort of read. I mean, when you come onto an existing project, there's like thousands of lines of code that are already pre-written. You don't have the opportunity to just like sit down and like read all the code. Basically, they throw features at you, and you find the appropriate section of code where you write that new feature, and over time you end up seeing all the different parts of code. Came time for me to really dig into some of the store credit stuff, and I came across, let me eliminate this, I came across this code. However, there was one modification, and that is that these two lines were in the opposite order. So let's walk through what happens in this code. Okay? Let's do this together. So let's say, again, this else only gets triggered if the store credit is equal to or greater than the amount due, right? So imagine that someone has $1,000 of Doggy Loot dollars, and they're going to pay for the whole purchase. What happens? So on line 5, the amount due is $0. That's cool. That makes sense, right? They're going to pay. They don't have to pay anything on their credit card. They're gonna pay for this whole thing with Doggy Loot dollars, right? Awesome. Now line 6, store credit. Let's reduce their store credit by store credit minus amount due. So let's say I have $1,000 in store credit. What is my store credit after this line? It's unchanged. I still have $1,000 Doggy Loot dollars. So if I have enough store credit to buy this whole thing, I can buy it and keep my credit. So I saw this and I'm like, this is really funny. Like, when I read this code, it seems like they're not getting a reduction in credit if they can pay for the whole thing. That's really, I'm reading it over and over. I'm like, it can't be. It can't be. And then I try it. And yes, you can buy stuff with credit and not get a reduction in Doggy Loot. And that had been in the code for like 6 months. And I was so happy that wasn't me who put that in, but we all make mistakes. Later at Doggy Loot, I did make a mistake in my code that cost the company tens of thousands of dollars. And I apologized to the CEO, and it was all good. Depends on your situation. I was lucky. But this is like, and the first thing I do is I start looking in the database. I'm like, if someone knows about this, if one of the customers actually figures that they don't see the code, but they just notice that they can keep on buying things with credit. And I couldn't find anyone who seemed to be taking advantage of it, but certainly inadvertently, people were buying things without a reduction in credit. So this is the worst kind of error, the worst kind of bug in your code, because you don't get an error message. Everything works, just the logic is wrong. And it's really hard to catch it. And in most cases, this would have been caught by the CEO coming to me and being like, we're doing like, the financials and something's weird here. And then I would look and find it. It happens to be I was just looking at this code and I was like, this seems weird. It can't be doing what I think it's doing. And yeah, logic is tricky. And this person who wrote that code is a very experienced developer, but people make mistakes. I think the main moral of the story is always test your code in real life, right? Test it out on the website, make sure it works. Yeah, but that's a story of what happens when 2 lines of code are out of order. I love that story. Okay, let's take a break, and we're going to start at 8:20.